specifically in 2 dimensions, though it's not written down. But the reason why we do vector subtraction is because that in some of our kinematic formula, excuse me, we're dealing with vectors, and sometimes we subtract them. And the most easy, clear example of that is v2 minus v1 over t. This is the one we do the most frequently, but there's other examples. So you can use both methods that we used for addition. If you use components, everything's the same except steps 7 and 8 on the little sheet, going through how to add. Just quickly, the little sheet being, oh, there it is, that sheet. Everything's the same except for this, okay? And in that case, it's really easy. Or you could do sines and cosines, and then you have to use the basic algebraic premise that a minus b, you're subtracting two things, is the same as a plus negative b. So you do the law of sines and cosines, but instead of adding, the vector, you add the negative of the vector. And we'll see that very shortly. Okay, there it is. So usually, like I say, we'll do vector subtraction dealing with v's, velocities. So v2 minus v1 is the same as v2 plus negative v1. Okay, but the first example I'm going to do is using x and y components, and we're going to move directly into that. And again, please pause if I've gone too fast. Okay, so here's our example. Please copy it down. First, we're going to do components, and then in the next video, I'll do a separate video for law of sines and cosines. So pause while you write this down, and I'm going to move on to the solution for part A. Okay, so using components, just want to remind you that if I say v2 minus v1, why we care is we're looking at a change in velocity. We want to know how much the velocity changes. Okay? So using components, just the 12-step program. First, decide on your positive direction, and I say east and north, but again, it doesn't matter. Just a quick little thing. Notice here I wrote v2 first. That's why I underlined here. I wrote v2 first and v1 second, and I keep that in mind when I do my solutions with components, is I always keep the v2 on the left, where usually it'd be on the right, because I'm subtracting. So it's find my direction, positive direction first. Draw the vectors, right? What is it? 30 is the magnitude, and 45 degrees east to north, or north of east, because it's going to be 45 degrees either way. And the v1 is just a horizontal vector. So going through step 3, 4, and 5 and finding the x and y components. So in this vector, here's my 45 degrees east of north, and I close in that vector, so add v2x and v2y, make my right angled triangle where this is my hypotenuse. Okay, x is touching the angle, so it's cosine, y is opposite the angle, so it's sine. Okay, and on the v1 side, I've got, it's just the horizontal vector, so v1x is 15, and v1y is 0. There is no y component to that, right? So looking at my positive directions, what's positive and what's not. Since I said north and east were positive, both of these are positive, but my 15 is negative. So I'm just going to draw a little negative sign in there. So it's in the west direction. Okay. So doing my v2, now this is where it's different, right? This is different than addition because I have a negative sign right there. I'm subtracting. So I go 30 cos 45 minus 15, which is the same as adding 15. So you get to 36.21 rounded, right? And same thing over here, 21.21. And this time I'm subtracting 0, so that's fairly easy. So there's my x, there's my y. Step number 9, I draw the vector. These are both positive, so they're going to be east and north. So I'll draw the x. Don't pick up your pencil, right? So here's where I start. I start drawing right here where my mouse is right now. I start coming across, draw my x, don't pick up my pencil, draw my y, and then my resultant vector, my change in vector, is from where I started drawing to where I finished, and the angle is close to where I start. Okay? Once I have a right angled triangle, you can use Pythagorean theorem to solve for the magnitude. of v2 minus v1. Remember, magnitude is the number plus the units. And then you can use tangent, inverse tangent, to find the angle. Opposite over adjacent. And then I get my overall answer. Now, putting a check mark on this is way harder. When you're subtracting vectors, it's much harder to picture what they should be. But the question is, how much should it change? Remember, v2 minus v1 means change in. And let's just look up at the original question. I start at 15 meters per second west. I end up 30 meters per second east and north. So the change has got to be east and north. And it's got to be pretty big because I'm going from 15 west all the way to 30 on the other side, on the east side. So it's hard to get your head around what's not reasonable, but certainly an east and north answer makes sense. It's changing towards the east and the north. So I'm going to put a check mark on that. Okay, so moving on. Actually, no, I'm not going to move on in this video. I'm going to make another video for the sines and cosines. We're going to do the exact same example using sines and cosines. Okay, but let me scroll through this whole solution just so you see all the parts and you can pause where you need to. So here's the start, step 1 and 2, step 3, 4, and 5. Step 7 and 8. Step 9, 10, 11, and 12. Okay.